undefined other basis. So measuring in the long basis introduces uncertainty, which reveals the eavesdropping. So no cloning theory means there another concept. Because of no cloning theorem, it is impossible to copy the quantum states. That means it is stated that if it is impossible to create the perfect copy of an unknown quantum state. That means even if the attacker cannot copy the transmitted quantum state, that means if attacker cannot copy a transmitted quantum state, any attempt to intercept will disturb the state and can be also detected. If somebody wants to intercept the quantum, the state will be getting disturbed so that we can detect it. So this is the basic model of quantum key distribution protocol. If you see the quantum key distribution protocol involves two parties like Alice and Bob's. They are using another party, Eve. Eve is a attacker which can access both channels. One is classical channel and the other one is quantum channel. So there are two channels we are using. One is classical channel, while we can transmit the qubits. The photons we can transmit in the classical channel, and we have to establish the secret key. Then for normal discussion, they can discuss in a so these qubits they can communicate using the quantum channels, and normal discussion they can discuss in the classical channel. The basic model of the quantum key distribution protocol involves two parties reported as the Alice and Bob's wishing to exchange a key. So both of them can access both of them can access the classical channel and quantum channel. Eve can also access the classical channel and quantum channel. So for quantum channel, they can use to transfer the photons or qubits, and classical channel, they can just any communication required for the protocol, they can discuss there. So one of the important quantum key distribution protocol is BB84 protocol. So that is so in 1984, the because of Charles Bennett and Giles Brasser published their first quantum key distribution protocol. So that is because of their name and the year. So it is BB84. So this protocol is based on Heisenberg's uncertainty principles, also no cloning theorem. So basic idea of this protocol is that Alice can transmit a random secret key to the Bob by sending a string of protons where the secret key bits are encoded in the polarizations of the photons. So the Heisenberg's uncertainty principle is used here to guarantee that the attacker cannot measure these photons and transmit them to the Bob without disturbing the photon states. So also in this case, if you see this example, so we can define binary zero as a pluralization of the 0 degree in the two bases we are using. One is rectilinear basis and the other one is diagonal basis. The binary 0 is degree 0 in the rectilinear basis and 45 degree in the diagonal basis. Similarly, the binary 1 can be 90 degree in the rectilinear basis and 135 in the diagonal basis. So that means thus a bit can be represented by the pluralizing the photon in either one of the two bases. Either you can use the rectilinear basis or diagonal basis. So you see that first what there will happen, Alice wants to share the secret code to Bob. So Alice uses the photon light particle to send 0 and 1s. She randomly chooses the directions for each photons, like 0, this directions or direction 1, this direction or this directions. This is in rectilinear basis, this is in diagonal basis. These photons travel through a channel like a fiber cable to Bob. If Eve tries to listen it, she messes up the protons, that the photon direction will getting changed. So step 2, the Bob also guesses the directions randomly when measuring the photons. Sometimes he guesses right directions. That means he get the correct bit. If he guesses wrong, he gets the incorrect bit. Nonsense. So later Bob tells the Alice which guesses he used, means which directions he used. Alice says that keep this, throw away the rest. That keep the bits that is guessed correctly through the incorrect bits. The bits they both agree are become the shared secret key. So this is the advantage. If you see this at the end, the Alice and Bob share the same secret key. So if Eve intercept or the intrusion introduces the errors that Alice and Bob can detect. So that is the advantage of the quantum key distribution, that ensures the secure communications. Also, it is resistant to quantum computer attacks. Also, the security in BB84 protocol depends on the quantum physics rather than the computational hard problems. So that is the things. If you see this diagram, if you see that. So this is Alice, this is Bob. So Alice either select to send the photon, either you can send this rectangle linear basis or diagonal basis. Alice sends, if you see. So this is means which diagonal, select the diagonal basis. Then diagonal basis, this means 0. Then Bob's detected event, Bob is guessing, measuring that it is in which basis? It is in rectilinear basis. So is guessing 1. So that is the rectangular basis. So now second one, if you see Alice sends this diagonal basis, then upper diagonal is sending the in upper diagonal direction, that is 1. And the Bob is detecting also in upper diagonal, that is 1. So that means this is correctly is guessing. So in third one, if you see that Bob is sending in which directions? Rectangular basis in upper or low, and this is 1. That means and Bob is measuring it is in which diagonal basis? This is 0. So similarly, in third case, if you see in this example, so what is the secret key? Can somebody can tell what is the secret key in this example? Which bits we means guessed correctly? Bob gets correctly. Which bits get Bob gets correctly? So what is first was 1 because he sends Alice sends 0 is getting 1. Alice sends 1 is getting 1. Alice sends 1 is getting 0. Alice sends 1 is getting 1. And Alice sends 1 is getting 0. Bob sends, so this is the, what is the secret key? The secret key is 1, 1, 0. That is the secret key. The secret key is 1, 1, 0. So now once they establish the secret key, they can use any traditional encryption techniques to communicate to each other. So one of the important traditional crypto system that we are using, that is one-time paired. So one-time paired is an encryption method proven to be unbreakable. So if the key is truly random and secret and used once, that means this one-time paired is a kind of encryption method. So where we are selecting the key randomly, also each key we are using only once. The key distribution, because whatever the key we are using in one-time paired, that key we are getting by using the quantum key distribution algorithm that we discussed in before. So also we can for encryptions, we are using different algorithms for one-time paired. So that we will discuss. So like this. So for encryption, this is suppose the plain text bit. The 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0 like this, and randomly generated key. So this key we are generating using the, so this key we are generating using the quantum key distribution algorithms. So then what we are doing, we are performing XOR operation. We are performing the XOR operations. If you perform XOR operation between 0 and 1, what is the output? 1. If the bits are same, we are getting 0. If the bits are different, we are getting 1. 0, 0 means 0, 0. So this is the ciphertext. Similarly, the decryption, we are getting the ciphertext, and this is the key we are using, and we are getting the plain text. Whatever the plain text we are getting the same plain text. So for encryption, decryption, we are using the simple XOR operations. So this is all about the one-time paired. And so, okay. So that is all about my presentation. So if any doubts, you can we can discuss. So if you are any query, I can ready to take if any query.
Hello, sir. Thank you so much for the presentation.
Yes.
Sir, I'm asking one question related like which encryption algorithm to use when, like cloud data I want to secure for a long time, or some WhatsApp message I want for a time being within a time span it should get decrypted. Like I am confused between RSA is used, EC is used, or AES, DS. Which one
So
I should use?
it depends on the requirement. Suppose you wanted to send that information to a particular person. Got my point? So if you wanted to send the information, then you can use better. You see that. So very simple question. So if you have a long messages, so you see that public crypto system is not suitable for transmitting a long message. Instead, we can use the symmetric crypto system. Got my point? A symmetric crypto system is works good for the means long communication. But in symmetric encryption, so what is the shared secret key we need? The shared secret key is exposed to outsiders, then the security will violate it. Got my point? To establish the secret share key, we can use the quantum cryptography, quantum key distributions. If your requirement is you wanted to transmit the message to multiple parties, so in that scenario, you can go for the advanced crypto system like attribute-based crypto system or some other crypto systems. It depends on it's a cloud scenario. In the cloud, what happens? We are sharing the data to the multiple users at a time. The data is encrypted, but the data should be accessed by the multiple party. So in that scenario, we can go for the attribute encryption. If you are using the symmetric encryption or public key encryption, the multiple copies of the same data we need to create. So unnecessary, it will waste the storage. Got my point?
Yes, sir. Yes, sir. Received. Okay, sir. Thank you, sir.
Okay. So any doubts, please you can ask. I'm ready to. So if you want to work with me, you can just send a message to me, email me. Then we can. I am also working in the machine learning based intrusion detection system, malware detection systems, IoT securities. A lot of areas I'm working. So recently I started exploring the quantum because I am working in attribute-based encryption, homomorphic. Recently I started exploring the quantum cryptography, then post-quantum cryptography. I'm gradually exploring. So okay. So anything you wanted information? So should we close the session or?
Yes, sir. Sir, Dr. Kamala Kanth, Sethi, sir.
Yes.
Today we have a wonderful session, sir.
Thank
you for contributing your valuable time and valuable presence for our 1 week ATAL sponsored faculty development program on quantum cryptography enabled autonomous underwater vehicles. Thank you for your wonderful deliverable, sir. Thank you very much, sir.
Thank you, sir, for the
Thank you, sir. Thank you, sir.
Okay.
Sir, please, sir. Ma Ritika, kindly conclude the session, ma.
Yes, sir. Dr. Kamala Sethi, sir, thank you for delivering an enlightening session and sharing your expertise with us today. Your insights on advanced cryptography, attribute-based encryption, and other topics have been very invaluable, sir. We appreciate the time you took to prepare and present your session today with us. We are grateful for the opportunity to learn from you and benefit from your knowledge, sir. Your contribution to the success of this faculty development program is greatly appreciated. Once again, thank you for your presence and thank you for the knowledge that you have shared with us, sir.
Okay, thank you. So, okay. So, should I close the meeting?
Yes, sir. Yes, sir. Thank you, sir. Once again, we are very much thankful for your session, sir.
Thank you, sir.
Thank you, sir. Hari Om, sir. Thank you, sir. Dear participants, thank you for joining with us. Tomorrow we will meet on day 3, session 5 session. Session 5. Thank you.